Welcome to our channel Sankalp Study Success. So in this video we are going to learn about Fermat theorem. Here what is the Fermat theorem, and there are few problems to solve. This Fermat theorem states that if P is a prime number and A is an integer in such a way that P does not divide A. P does not divide A. So then P power P minus 1 is congruent to 1 mod P. From this equation, what can we understand is A power P by A. We can write it A power P minus 1 in the form of A power P by A, right? So, it is congruent to 1 mod P. A power P by A. Now, if you transfer this A from LHS to RHS, then it becomes A to the power of P is congruent to A mod P. So, we will get this equation like this. Okay. So, what does this Fermat theorem states is, if P is a prime number and A is any integer, then and also P does not divide A, then we can say that A to the power of P minus 1 is congruent to 1 mod P. Also we can say that A power P is congruent to A mod P. Both are one and the same. So let us prove this Fermat theorem as well. And so here first, in order to prove this theorem, we will consider first P minus 1 positive multiples of A. Okay, here we are having A, right? So we have to consider P minus 1 positive multiples of A. So multiples is nothing but which will multiply A, right? So 1 into A, 2 into A, 3 into A, and so on like that up to P minus 1 into A. These are nothing but the first P minus 1 multiples of A, where P does not divide A. Where P does not divide A. This is the important point. So here, from the above set of integers, no two integers are congruent modulo P, right? And they are not also congruent to 0 because they will not divide A. P will not divide A. P is nothing but any integer. So these all integers will not divide A. So these are not congruent. That means let us consider UA is equals to VA mod P. See here, UA is congruent to, which is not equal to, which is congruent to VA mod P, where U comma V belongs to 1, 2, 3 and so on up to P minus 1. U and V belongs to 1, 2, 3 and so on up to P minus 1, where U is not equal to V, because if U is equals to B, then it becomes 0. That means it is divisible by P. But here they are not divisible by P, right? P or A also. So we can write this equation as UA minus VA is congruent to mod P. That is what 0 mod P, right? Because remainder is 0. So if that means, what does it say? P divides U minus V of A. That is nothing but UA minus VA only. U minus V of A. That means this divides either U minus V or it divides either A. That means as this belongs to these integers and also U is not equal to V, so it will not divide U minus V exactly, right? So P does not divide. That means what we have considered is this divides, P divides U minus V, but it contradicts our statement. P does not divide U minus V. See here, from the hypothesis we have P does not divide A. So hence UA is congruent to VA mod P, and also UA is congruent to 0 modulus P. Okay. So now from the above set of integers, what are those integers? 1, 2, 3 and so on up to P minus 1. Here we have considered this equation, right? Here we said that P does not divide A. So let us multiply all the terms, that is 1a into 2a into 3 and so on up to p minus 1 into a, which is congruent to 1 into 3 into 1 into 2 into 3 into and so on up to p minus 1 mod p, right? This is the equation which we get generally. So from here, what can you write? 1 into 2 into up to p minus 1 means p minus 1 factorial and also a to the power of p minus 1, because we are having p minus 1 number of a's. So which is congruent to, this is p minus 1 factorial only, obviously, mod p. So you can cancel p minus 1 factorial and p minus 1 factorial on both the sides, right? So you will be remained with a power p minus 1 is congruent to mod p. Okay, what is this mod p? Which is nothing but 1 mod p. Okay, if there is nothing, then you can write it as 1. So now a to the power p by a, you can write it in this way, a power p minus 1. So now a to the power of p is congruent to a mod p. So we have proved it, right? We got the same equation, so hence proved. See it here. If p is a prime number and a is an integer, then if p does not divide a, then you will get it as a power p minus 1 is equals to 1 mod p, which is nothing but a power p is congruent to a mod p, right? So we got the same thing here. This one, a power p minus 1 is congruent to 1 mod p and a power p is congruent to a mod p. Okay, so you can also call Fermat theorem is also called as Fermat little theorem. You have to remember these names also. Fermat theorem and Fermat little theorem, both are same. So now let us solve one question, which is using Fermat theorem, prove that 4 to the power of 13,332 is congruent to 16 mod 13,332. So now let us write it in the form of a power p minus 1 is congruent to 1 mod p. Okay. So now writing 13,332, this is the given thing which I am writing here, 16 mod 13,331, right? So now let us write 13,331 minus 1. Am I correct? 13,331 minus 1. This gives 330, right? Let us write 13,331 plus 1, which is nothing but 332. You will get this thing only. 16 mod 13,331. So now, if you write 13,331, then it becomes 4 mod 13,331. Is it not? Because if you are removing 1 4, you have to remove 1 4 from here also. So here if you write 13,330, then if you have removed one more 4 from here, you have to remove this 4 from here also. So you will be remained with 1 mod 13,331. So now from these all equations, these are the equations which we got till now. So now let us consider, since 11 is a prime number and it will not divide 2, correct? And does not divide 2. That means what? 11 is a prime number and 2 will not divide 11, right? 2 is a prime number and 11 is also a prime number, so it will not divide 11. So from Fermat theorem, now how can you write it as 2 power 11 minus 1 is congruent to 1 mod 11? Am I correct? We are just considering it. 2 power 11 minus 1 is congruent to 1 mod 11. So from here, the 2 power 11 minus 1 is nothing but 2 power 10, right? 2 power 10 is congruent to 1 mod 11 here. So what does it happen is, now 2 power 5, if you consider 2 power 5, then again it becomes 1 mod 31. Am I correct? 2 power 5 is nothing but 32 and 1 mod 31. Okay. Now, if you power with 68, it will be congruent to 1 to the power of 68 mod 31, right? Am I correct? Now, what does it become? 68 into 5 will give you, I think it is 340, right? Yeah, it is 340, which is congruent to 1 to the power of 68 mod 31. 1 to the power of 68 is nothing but 1 only, right? So 2 to the power of 340 is congruent to 1 mod 31. So now here we got 2 power 340, then which is 340, which is divisible by 11 into 31. Am I correct or not? 11 into 31 is nothing but you will get 1131 times is nothing but 321, right? So 340 is divisible by 11 into 31. That means I'm 340, that is a power of 2. Okay, 2 power 340 minus 1 will be divisible by 11 into 31. So you can write this as 2 power 340 is congruent to 1 mod 341. So we can say that even though 341 is not prime, it is not prime number, right? 341 is not a prime, but still you can say that 2 power 340 is congruent to 1 mod 341. So hence we are proving the Fermat theorem, hence proved. So here what did we consider? We have considered 11 is a prime number and 2 is not dividing 11. So in the Fermat theorem we have written it, and if you simplify that, then you will get 2 to the power of 340 is congruent to 1 mod 341. Okay, this is the Fermat theorem and an example. So now let us solve one more question, which is prove that log 7 base 3 is irrational. Given number is log 7 to the base 3. How do you prove that it is an irrational number? First of all, what is a rational number and irrational number? Rational, it is in the form of p by q, and irrational, it is not in the form of p by q, right? So that means what? Log 7 base 3 should not be in the form of p by q. So now let us consider as it is in the form of p by q. That is, I am taking it as u by b, u by v. You can also take it as a by b, l by m, x by z. You can take any number of variables, but it is in the form of p by q. So now how can you express it in the form of exponential form? Exponential form is 7 is equals to 2 to the power of u by v, correct? 7 is 7 here only, so this 3 to the power of u by v will go to the RHS side and you will get it as 7 is equals to 3 pi u by v. Now 7 power v is equals to 3 power u, right? Now let us say this is equals to m. Say it is m, okay? You are just considering it as m. So now this means that the integer m is greater than 1. It is expressed as a product of prime number in two ways, right? M is greater than, if m is greater than 1, then you can express it as in the form of prime numbers. So that means what? You are expressing it in the form of prime numbers means the given log 7 base 3 is not a rational number, but you have considered as a rational number, right? If it is a rational number, then you will not, if it is a rational number, then you might got it in the form of p by q. But here m is greater than 1. You can express it in the form of prime numbers in two ways. So it is not a rational number. That means it is contradicting our statement. It contradicts our statement. It contradicts our statement. That means given number log 7 to the base 3 is irrational. Okay. Log 7 to the base 3 is irrational. So we have proved it by considering the given number as a rational number. We are just assuming it as a rational number u by v. Now by converting this logarithmic form into the exponential form, you will get 7 is equals to 3 par u by v, and you can write it as 7 par v is equal to 3 par u, which is equals to m. Let us consider. And here m is greater than 1, which can be expressed as product of primes more than 2 product of primes. So here you can say that it is not a rational number. That means we have considered it as rational, but here it is not a rational number, so it contradicts our statement, and you can say that log 7 base 3 is irrational. Okay, I think it is clear. Now let us go into the next question, which is you have to prove that root 11 is an irrational number. What shall we do? The first step is, given number is considered as a rational number. Let us consider root 11 is equals to u by v. This is the first equation, right? Now, squaring on both sides. Why we are squaring on both sides? So that you will get 11 is equals to u by v whole square. Root 11 whole square, right? Which is again 11 only. So 11 is equals to u square by v square. This is the thing which we got. So now from here you can write it as u square is equals to 11v square. Let us consider this as equation 2 because this is equation 1, right? So now u square is divided by 11. Here u square is divided by 11. So u is divisible by 11, right? If u square is divided by 11, so let us write here u square is divided by 11. That means u is also divided by 11. Okay, that means what? U is equals to 11k. U is nothing but 11k. Let us consider this as equation 3. Now you can substitute this 11k in equation 2, right? So that you will get 11k whole square is equals to 11v square. Okay, 11, here 111 and here 111 will be getting cancelled. That means here let us write completely 121k square is equal to 11v square, and here you will this 11 and here 11 times it gets cancelled, and you will remain with v square is again 11v square, 11k square. That means what? V is divided by 11. V square is divided by 11. That means v is also divided by 11, right? And from equation 2 and 3, from equation 2 and from equation 3, we can say that u and v is having a common factor because u is dividing 11 and v is also dividing 11. That means we have a common factor 11. 11 is the common factor. That means what? It is contradicting our assumption. Our assumption is false, and hence you can say that root 11 is an irrational number. Okay, so now I think it is clear. So let us recap once more. Let us consider it as a rational number, and you can express it as u by v. So by squaring on both sides you will get this equation u square is equals to 11v square, so that you can say that u divides 11 and u square divides 11 and u also divides 11. That means what? 11 is a factor of u, right? So now let us consider u as 11k, so that you can substitute 3 in equation 2. Here what we are doing, we are substituting 3 in equation 2. 3 is nothing but 11k whole square, which is equal to 11v square. 11k whole square means 121k square is equals to 11v square, and if you cancel 11 on both the sides, v square is equal to 11k square. That means v square also divides 11, so v also divides 11. That means v also has a factor of 11. So u and v have 11 as a common factor. That means it is contradicting our assumption. So we can say that root 11 is an irrational number. It is an irrational number. Okay. So thank you for watching the video. Let us meet in the next video with a new topic, linear congruence. Okay.